First of all, thank you very much for choosing the products of Jiangsu Rutong Petrol Machinery Co., Limited. This video mainly introduces the field operation methods and precautions for the TXGN type casing running tool CRTi. The TXGN type CRTi is a purely mechanical casing running tool used in oil and gas well completion operations. It can both suspend casings of corresponding specification and transmit the top drive's torque to the casing to facilitate casing makeup and breakup. If resistance is encountered during casing running, the CRTi can perform real-time mud filling and quickly establish circulation to ensure smooth casing running operations. This device can also be used in combination with other equipment based on actual field requirements. Composition of the CRTi. The CRTi mainly consists of the following components. 1. Central shaft. The central shaft connects all units of the device. Its upper end is connected to the top drive swivel, bearing and transmitting the main load. 2. Mechanical control assembly. The mechanical control assembly is the core of the device, primarily composed of a cam mechanism. Its functions include locking, unlocking the device, force conversion converting radial force to axial force, and transmitting torque. Slip assembly. The slip assembly mainly consists of slips and slip retainers. Its primary function is to grip the inner wall of the corresponding casing, enabling pipe suspension and makeup breakup. Different casing sizes and weights require corresponding gripping units. Seal assembly. The seal assembly mainly includes pica cups, cup racks, and guide shoes. The guide shoe is used to guide the device into the casing. The cups adopts a flared self-sealing design, providing the necessary conditions for mud circulation. Equipment selection. Before selecting the equipment, it is necessary to first understand the casing parameters and total suspended weight, and then choose the appropriate model. Our company's CRTi is divided into 3 models: TXGN 200, TXGN 320, and TXGN 500. Based on the casing size and weight, select the appropriate slip assembly and seal assembly. For example, for 9 to 5/8 casing, the TXGN 320 model is divided into 3 weight ranges: 32.3 to 40 ppf, 40 to 47 ppf, and 47 to 53.5 ppf. The slip assembly mainly includes slips, mounting plates, and cover plates. The seal assembly mainly includes pica cup racks, pica cups, reset rings, and guide shoes. Depending on the size of the top drive center pipe thread connection, prepare an adapter sub. Additionally, select suitable extended lifting links or extension links as needed. The total length of the lifting links is related to the equipment length, adapter sub length, and top drive model. If the wellhead is misaligned or when running threaded casings, for example, thumb threads, consider using a box thread protector to better meet field requirements. Installation. Hoist the assembled CRTi using a lifting plug from the catwalk above the wellhead until perpendicular, then apply lubricant to the pica cup sealing surface. During lifting, avoid collisions or scraping with the ramp or derrick. Protect the lower cup at all times. After inserting the CRTi into the casing, remove the lifting plugs. Slowly lower the top drive to the appropriate position and rotate the connection device gently. Use manual tongs to grip the locking sleeve with the CRTi. After engaging the tongs, personnel should stay clear. The makeup torque should be at least 1.25 times the required casing torque. After connection, spray an identification line on the joint for daily inspection and judgment. After installation, inflate the CRTi center nozzle with an air gun, typically to 0.6 to 0.8 megapascals. Operation process. When the wellhead is relatively aligned, the driller is skilled, or for standard casings without strict makeup curve requirements, the CRTi can be used for makeup. Use a crane or single-joint elevator to transport the casing to the ramp or mouse hole. Lower the top drive to the wellhead, where the elevator can grip the casing on the ramp or in the mouse hole. Raise the top drive to lift the pipe string until it is naturally vertical to the wellhead. Lower the top drive to insert the CRT into the casing, with the anti-collision plate resting on the casing collar. Observe via the monitoring camera and adjust the casing position using the link tilt device if needed. The driller applies downward force and rotates the device clockwise to activate the CRT. Continue rotating while maintaining the top drive's natural suspended weight. When torque exceeds 4 kN, the CRT fully grips the casing and can suspend it. Continue rotating clockwise to begin threading the casing connections. Simultaneously lower the top drive, maintaining natural suspended weight to avoid axial force on the threads. Monitor the top drive torque until the required casing torque is reached. Natural suspended weight refers to the top drive's own weight when not suspending the pipe string. If the suspended weight is too light, a backup tongue should be applied to the lower casing to provide counter torque. After the CRT grips the casing can be lowered. Gently raise the top drive to release the slips. After removing the slips, lower the top drive, and the CRT will drive the entire casing downward. If rotation is needed while lowering, the top drive can only rotate clockwise. When the elevator reaches the wellhead, open it first and continue lowering until the casing collar reaches the proper position. Swing the elevator to the ramp to prepare for the next joint. When the casing collar nears the wellhead, set the slips to grip the casing. Operate the top drive to apply downward force, then rotate counterclockwise until the device locks, alignment marks match, and the CRT disengages from the casing. Then, slowly raise the top drive to retrieve the CRT. If resistance is encountered while lowering, mud filling and circulation can be initiated. After circulation, ensure the standpipe pressure is released before slowly withdrawing the CRT to prevent excessive mud spray. During lowering, the CRT can also rotate the entire casing string clockwise to aid running. Rotation must be clockwise only. CRT with power tongs. If the wellhead is misaligned, personnel are inexperienced, or casing cross-threading is likely, power tongs are recommended for makeup. After installing the CRT, use conventional elevators and slips for casing running. If resistance occurs, insert the CRT for mud filling and circulation. This workflow improves efficiency. Lower the top drive to the wellhead, where the elevator grips the casing on the ramp or in the mouse hole. SLX-type elevators are recommended. After securing the elevator, insert the safety pin and slowly raise the top drive to lift the pipe string until vertical. Use a pipe handler or other methods to stabilize the lower end of the casing and prevent impact. After the casing reaches the wellhead, remove the thread protector and install the casing stabbing guide. After aligning the casing, use power tongs for makeup until optimal torque is achieved. Power tongs can reverse rotate to engage threads, reducing cross-threading risk. Start with high-speed rotation, then switch to low speed once torque exceeds the display value. For long-threaded casings, release and reset the tongs midway. After makeup, verify the torque curve is acceptable and retract the tongues. Slowly raise the top drive to remove the slips. Lower the top drive to the wellhead. If resistance occurs at any point, set the slips, insert the CRT, and perform mud filling and circulation. Open the elevator, tilt the links, and prepare for the next joint. Remove the box thread protector, repeat the cycle. CRTi activation, release. Activation and release are critical for successful CRTi operation. For clarity, a simulator is used here. Yellow equals CRT, blue equals casing, red equals top drive. Activation. Apply 2 to 3 tons of downward force and rotate approximately 20 clockwise to release internal hooks. Restore natural suspended weight and continue rotating until torque exceeds 4 kN, ensuring full casing grip. Release point 1, under natural suspended weight, rotate counterclockwise until alignment marks nearly match. 2. Apply 3 to 4 tons of downward force until the exposed part black NVIDIA is fully pressed into the anti-collision plate. 3. Continue rotating counterclockwise until marks align and both upper, lower plates rotate, indicating release. A scenario may occur where the alignment mark overshoots as shown in the video, preventing successful release. This is caused by insufficient downward force during the pressing step, which inadvertently triggers the unscrewing mode. To resolve this, return to the natural hanging weight, rotate the CRT clockwise by half a turn, and then repeat the standard release procedure as described above. After each use, perform basic maintenance by inverting the CRT into an installation bucket. Tighten the bucket bolts to clamp the CRT's locking sleeve. Use a pry bar to rotate the anti-collision plate clockwise, opening the slips. Clean thoroughly, apply thread grease to reduce wear, and reassemble. Rotate the anti-collision plate counterclockwise for release. Check slip-to-shaft clearance amid one slip for testing. The above inspections apply only to routine maintenance during daily use, under normal operation. Every 6 months, perform a disassembly inspection as outlined in the maintenance manual. Conduct a non-destructive inspection and DI of the threaded section of the central shaft. After 1 year of use, perform a full non-destructive inspection of the central shaft in accordance with API 8C. Simultaneously, check the clearance of internal threads and inspect for severe wear. Replace relevant components if necessary. This concludes the video. For questions, please contact our company. Thank you for watching.